one of you emailed me inside WebAssigned and said they need some help with question number 8, and this is question number the similar problem from the summary worksheet. And I don't know if they watched the Scott Stevens video, so I figured I'd do this one here. So the first thing we should do is, let's see, they're asking us to find the mean. So to find the mean, we have to find the sum of these numbers. Okay. So I did this with a calculator, and I found that the sum of these numbers was 383. And then to find the mean, we're going to divide by how many numbers we have, and that's 5. So, and then of course I'm going to round a little bit here. So I got a mean of 76.6-ish. Okay, now to get the median, we need to arrange the numbers in ascending order. So let's see, the smallest one here I'm seeing is what, 68? And then there's another 68. And then there is a 70. Then there is a 84. And then a 93 is the last one. And the median will be the middle number, and since we have an odd number of numbers, 70 will be our median, because that's the middle. There's two numbers less than that and two numbers above it. So that tells me the median is 70. Now if there had been 6 numbers, we would have had to, let's how I write this down. Now suppose that they'd given us a 100. Okay. What we would have had to done is take a look at the 2 middle numbers and then find the average of those. So we would have done 70 plus 84 divided by 2. Okay, and that's what you do when you have an even number of numbers and look for the median. Most important, make sure you have them in order, ascending order. For the mode, we're going to look at the number that occurs the most frequently. And I'll be honest with you, a mode I like to reserve for categorical variables. So I mean, it doesn't make much sense to me to say that a number. I mean, I guess we can see that number occurs most frequently. I always usually find it kind of awkward, but I mean it works, and they're asking for it here, and we certainly can find it. And I'm seeing 2 68s, and so since we have a repeat, the mode will be 68. Now the other thing that will happen is sometimes you'll have more than one number that repeats, and sometimes, and I'll be honest, we haven't watched that video about what Scott Stevens does for this, but some textbooks will talk about bimodal distributions, or number sets that have 2 modes. If there's more than 2 modes, 2 numbers that repeat the same number of times. Like if there'd been a 70, another 70, then we would say they were 2 modes, 68 and 70. But if there had been another number, like more than 2 modes don't exist. We say there's no mode, usually. Okay, to find the range is just the max number minus the min number. So in this case, we've got a maximum of 93, a minimum is 68. We'll subtract those, and that'll be the range. Now to calculate the sample variance and the sample standard deviation, it's a whole process that Dr. Stevens walks us through. I also prepared this, and I'll walk us through it too in the next. The easiest way to find the variance and standard deviation by hand is to take your numbers and set them up in a table. So all I did was I set up this table and I put the values that are here, and then you need to find the mean, because the variance or standard deviation variance is a measuring like the average distance between the numbers and the mean. So what you do is once you kind of find the mean, and symbolically what we're doing is we're saying x minus x bar. Okay, or if you've got a population standard deviation, it's x minus the population mean, mu versus x bar. Okay, but this problem specifically is asking for the sample standard deviation, so we know we're going to use x bar. So then all I did is I took 68, that's our first number here, and I subtracted 76.6, and that's how we came up with that number. And I did that for each number. I said 84 minus 76.6, and then the 93 minus 76.6, and that's what's happening here, and that's how I came up with these numbers here. Okay, so that's this part of the formula. Now the next part of the formula says, hey, take those differences and square them. Because if we just add up these numbers here, we're going to get 0. And you can check it and see. Or maybe if we round it. I rounded these to get, so probably if I added up the rounded numbers, the rounded differences would be exactly 0. So then you have to square those differences. And so what we did, and you've got to remember order of operations, if you take negative 8.6 and square it, that's like saying 8.6 times 8.6, or negative 8.6 times negative 8.6, and we know that a negative times a negative makes a positive. So that's one reason why we square them, to get rid of the negatives. Okay, and that's what I did for each one of these. I took this number and squared it. I took this number and squared it, and so forth. Okay, now the next part of the formula says, hey, you got to take those square differences and add them up. Find the sum of them. So that's what I did here. I just added up these 5 numbers, and that's where we got the sum. Then to get the sample variance, you divide by 1 less than the number of numbers that you're working with. Since I have 5 numbers, I divided this by 4, because 5 minus 1 is 4. Then to get the standard deviation, you take the square root of that. And that's how you calculate the standard deviation. And as you can see, I got 11.3 using it this way. So this last question down here asks us, and this is the next question in the web assign homework, suppose that we change one of those 68s to a 50. What happens? Well, I'm going to make a guess here before I actually calculate it. I know what happens because that number is so much smaller than 68. It's probably going to decrease the mean. I'll suspect it won't change the median, because the median is still the middle number, and we haven't changed the middle number. Didn't change it. It changed the mode. Now there's no mode, right? Because we don't have the double 68s. Now, what happens to the range? Instead of being 93 minus 68, we're going to do 93 minus 50. So the range is a whole lot more. Is that 43? So that's going to increase the variance in the standard deviation, because there's a lot more spread around the mean, around the mean. Okay, so we've already said what it would do. Now let's make sure that I was right. So here's what I'm seeing. I'm seeing it did decrease the mean. What else happened? It increased the variance, and it increased the standard deviation. And I'll leave it to you to see that it didn't change the median. Okay, so that's what the prediction did, and that's what happens. And something we'll explore next week is how that's an outlier. I mean, the outliers start really having an effect on the mean and the standard deviation, not so much on the median. Okay, hope that helps.